For E2 mechanism, it happens in one step. There are no carbocation reactions. If it helps draw out all the elements on the substrate, that means draw out all the H's and the CH3s, do that. And it favors strong bases. And you have to find the major product. So the first step, the strong base can attack either hydrogens that you draw. So you should be drawing 2 different hydrogens on this element. And the nucleophile can attack both, but at the end you'll be determining which one is the best one. Anyways, so the strong base can attack the 2 hydrogens. Step 2, the halide leaves, and then after that you are left with your substrate, and you can put a bond on either side of those hydrogens. But the best spot for the hydrogen, for the bond to be at, is with the Zaitsev product. And the Zaitsev product looks like the snake with the bond in the middle, and it has 2R. And it's trans 2-butane because they're at different areas. It's the most stable alkene. The Zaitsev product is the most stable alkene, and it has the snake in the middle and the bond in the middle. Because the CH groups are farthest away from each other. That's why. There can be 2 products with it. And it favors a secondary carbocation. So the major group is the Zaitevs, which is, like I said, the snake or the table, and the minor is the Hoffman, and it has the bond at the end. So, like I said, the step is you identify the nucleophile, if it's strong or weak. It should always be strong. And the leaving group will leave. Always draw the hydrogen on it. The base attacks the hydrogen disappears, and the hydrogen bond attaches. Always form the major, never the minor. The terminal one, the terminal bond. Hydrogen bonds always matter with the E2 reaction. Now when you have a bulky base, the ending product will have a bulky base on it. And all the drawings should look similar to this. It should be 1, 2, 3, 4. It should have a 4-carbon chain with 1 hydrogen on the 2nd carbon and 1 hydrogen on the 4th carbon. But the best drawing should have Zaitsev, which is the bond in the middle. That is the major. Now, if it's sterically hindered, and you know what sterically hindered means, you pick the Hoffman product, which is the terminal one, which has the bond near the end. And sterically hindered, and that's with the butyl group, okay? So the best is the primary, then the secondary, then tertiary. The bad leaving group is the Hoffman product. It always wants the bad leaving group wants the primary one for the E2 reaction. the more stable it is. It has a conjugated double bond, which means that the bonds are kind of sort of near each other. The worst one is the minor product, where the bonds are farthest away from each other. The major products is when the bonds are close to each other. So basically the steps for this is the base attacks the H bond forms another bond, leaving group leaves, and then you find the major product, which can be the terminal alkane, which is in the middle. It's not the terminal alkane, but it's the bond that is in the middle. That is basically E2 reactions.